Hey everybody, in this video I'll show you one method for drawing Lewis structures. It's my favorite way because it means you'll pretty much always end up with a structure that is correct at the end. In this particular video we're going to do it for the molecule BrF3. Let's get started by doing step one, which is arranging the atoms. This means you have to identify an atom to be considered the central atom. Usually it's the one that's written first, in this case Br. It's also usually the atom that there's just one of, in this case again, Br. The other atoms you're going to put symmetrically around that central atom. It doesn't really matter where you put them, so just distribute them like so. Also part of step one is counting up the total valence electrons that each of these molecules brings in. And we're going to write that total here just to make sure we've got it and we're keeping track of it as we go. Bromine has 7 total valence, as does each fluorine. If I add all of those together, that's a total of 28 valence electrons. Step 2 tells me what to do with those 28, first by adding in single bonds to connect all the atoms together. Need a single bond here for this fluorine, here for this one, and here for this one. Remember, each of those single bonds uses up 2 electrons of my original total of 28. That means of the original 28, I just used up 6, and there are only 22 electrons left to use. Step 3 tells me what to do with those 22 by giving octets, that's that magic number of 8 total electrons, specifically to the outer atoms first, and yes, that matters. That means we're going to ignore the bromine and take care of only the fluorines first. Each fluorine already has 2 electrons with that single bond, so to bring it up to an octet of 8, I have to give each fluorine 6 more, and I'll do that to each of those fluorines now. After step 3, I'm going to take my 22 electrons that I had before and subtract out what I just used. A total of 18 electrons was used to give octets to each fluorine. That means there's only 4 electrons remaining. Step 4 tells me to give any extra electrons to the central atom as lone pairs. Lone pairs look like this. Since I have 4 total electrons, that's going to have to be 2 different lone pairs. It doesn't really matter where you put those 2 lone pairs as long as there is space, so let's put them right down here. I've now used all of my original valence electrons. There are none left, which is good. You have to use all of them that you started with, and we did. We'll end it with step 5, which is making double or triple bonds if the central atom has less than 8. So we have to actually go back one more time and count how many electrons are surrounding our central atom. Let's switch colors. I'll go to orange and do that. You can count with me. Each single bond is 2 electrons. So I've got 2 here, 2 here, and 2 here. That's 6. I've also got these lone pairs, which is another 2 and another 2. Something interesting happens at this point when you actually count how many electrons are surrounding this bromine atom. You actually get a total of 10 valence electrons, which isn't really addressed anywhere in step 5, right? If we go back and read that, it says make double or triple bonds if the central atom has less than 8, but it doesn't say what to do if there's more than 8 like we have here, and it doesn't say anything because you don't have to do anything. If an atom is big enough, and bromine is, it is allowed to go past 8 valence electrons with no additional action needed by you. There is a name for atoms like this. They are called expanded octets. And all you really need to know is that when an expanded octet happens, it's okay, and you just leave it alone. Our final step would be to redraw everything now that I know what everything looks like in this Lewis structure. So there's my final Lewis structure for BrF3.